All right, people, these are the answers to one of actually last year's fake lab. They recommended that you do 25, take it 25 minutes, and the national average was 6.57 out of 10 points. Um, but the standard deviation was um 3.22. So, there's a wide, it was kind of maybe like you got it or you didn't kind of thing a little bit. All right, and a ton of reading. Kind of unnecessary. I mean, they didn't have to make this so complicated. So I'm not going to read it so you can read it on your own, but basically, this is a sophisticated way of, without energy loss, giving something height so that it kind of falls out of the box, right? Because if it was a pendulum, you'd have to like use a razor blade to cut the string or something. Anyway, you start at point A with a height and you end at point B with some velocity. And you got to read a whole lot to figure out that that's really what's going on. And I'm like, is this a physical pendulum? Like, what's going on? Anyway, and what you're trying to figure out is G. So don't make these fake labs more complicated. Just look at the fundamental physics. And if you set up the fundamental physics correctly, there's going to be some relationship with what you can measure and what they're trying to get you to find. All right, so I will try to spell out where the points are so you can score this yourself. And again, my rough sense is you want the average is going to give you a 3-ish. Maybe a tiny, tiny high 3, not because I think, people get 1s and sometimes 2s are like skewing things way low. Anyway, okay, so A, describe an experimental procedure using the describe setup. So you this is worth 2 points, and you again, don't overthink this. You will measure the height multiple times. Like you will take whatever 15 different, like, say as many as you want. Don't go crazy, but you're not really doing it. So say you're going to do 20 different heights. And then you will set up the sonic rangers and measure 20 different speeds, and you'll make a data table. Like, I'm not really, don't don't overthink that. And include to reduce experimental uncertainty. This has come up over and over in the last fake labs. Basically, don't do, the labs that we do in my class tend to be one shot because I want you to understand the ideas, and doing it 50 times is not going to help you. You're going to get better data, but it's not going to help you understand the concepts 50 times better. So reducing experimental uncertainty just means, do 50 trials and have a computer analyze, do a statistical best fit line. Okay. Sorry, that was a lot of talking, but basically, you're just going to be talking about measuring carefully with a ruler, different trials, make a data table, measure this, measure that. Okay, and then describe how the data collected could be graphed and where the heck are you going to get G from. So that was worth, I think, 2 points. Sorry, I'm reading because this was not a hard problem. No offense, I'm kind of just looking at the key. I wrote it out, but so what you want to be able to, this is the physics. So sorry, I'll stop out. So you have initially MGH, it turns into 1/2 MV squared. So you don't even really need to mass the block, that cancels. You have some options. What I believe I chose to do was to graph v squared. So if you solve this for v squared, it's equal to 2gh. And you could graph v squared versus h, and then your slope is 2g. For whatever reason, I decided to graph 2h, and then my slope actually is g. So you get a point for understanding, and you had lots of options, like the scoring rubric, which you can find online. The scoring rubric said, you could graph v squared versus h, v squared versus 2h. You could graph the square root of v. sorry, you could graph V is the square root of 2G square root of H. So you could have graphed V versus square root of H. Lots of options. The slope will be different, but it'll still be related to G. So if you graph V squared versus 2H, then what's left over is G. So G is your slope. So I know when all around the world say 1 point for saying this is the physics, energy is conserved, and then another point for connecting that physics to something that's going to yield a line. Um, okay, so we're at 4 of the 10 points if I'm doing this right. Okay. Then I like C because C gives it a little bit of twist, and you're like, oh, now energy isn't conserved, and we're looking for mu. So again, we're still talking about energy, so we're gonna have mgh just like before, but now we have plus the work done by friction equals 0. And then you're going to measure this distance d. They're calling it x max, sorry, x max. So the work done by friction, and be careful whether they want you to find mu or F, looks like mu. So the work done by friction equals FD cosine of 180, because that angle is the angle between the motion and the force, which is 180. Friction equals mu m. Be careful, I always drop something here because you got two things. All these three things together are the force. And then that's a -1. Okay, so you have minus mu m g d equals 0, where d is x max, sorry. And the mass cancels again, yay. So in this experiment, oh, and the G cancels as well, which is nice. So in this experiment, you get H equals mu D, but D is X max. So, and you're looking for mu. So if you graph H versus X max, which makes sense, right? You lift it higher, it's going to go a greater distance. You get a direct proportion, and the slope is mu. Okay. So I thought that was kind of cool. That is worth C. It looks like it is worth 1 point for explaining, for doing this physics here. And then you're going to the table, which then they give you the table, indicate the quantities. Again, looking at hopefully this makes sense. I'm trying to keep this shorter. Be careful if you're making a table or a graph. They want you to label the units on the axes. Here they don't say units. And then so you get 1 point for labeling the axes. So that is free points, except you got to know what you're doing. H is in meters and X max is in meters, excuse me. That's worth a point. You get a point for plotting data points. Again, I'm just going to put some points at random. I have explained before how to spread your graph out, so I'm not going to do that again. That's in the previous video answers. You are going to use the ruler that you're going to take into the, oops, what do we want? Not the eraser. You're going to use the ruler to find the best fit line that has what they say equal points, like above and above below the line. And then so you get a point for saying, for plotting the points. Okay, so free points. You get a point for drawing the right curve. So if you draw, your goal is not to say, hey, how many of these points can I hit? The goal is to try to by sight average them out. So you would not get a point for this lower line because all of the points are above it. Okay, and then you get a point for understanding that the slope is mu. and you get a point for actually calculating the slope. And what they got with their data, I didn't do it because I'm like, okay, this makes sense. I can explain in the video. They got a mu of 0.38, but they took anything from zero point 0.3 to 0.5. Because again, you're doing this all by hand. All right, so I have explained fake lab, that process of the graphing fake lab. So I don't think that's worth either of our time. If that's still rusty, go to the module on fake labs. Lots of examples there, and or one of the other mini APs where I actually took more time to show you the graph. Okay, so that was, and if you're like this was still too confusing, search 2025 question 3, rubric. It is on the College Board website. So again, I thought that one was pretty straightforward. Once you figured out what the heck was going on, like this whole thing, first I thought, but this is gonna be some weird, complicated angular momentum stuff. All right, hope that makes sense.